Hi everybody. In this lecture, I'm going to talk about data selection and filtering, part 1. In this lecture, you will learn how to set up a data selection based on a table, rows, operations, and columns. Select rows with where clause, select rows with filter clause, ensure data availability for filters, and perform columns mapping. In Oracle Golden Gate, you can select which tables you want to replicate, which rows you want to replicate, which operations you want to replicate, and even which columns you want to replicate. You can also perform data manipulation and transformation at either the source side or the target side. However, in most scenarios, data filtering is configured in the replicate process side. You will learn how to perform all of that in this lecture and in the next lecture as well. Oracle Golden Gate does not support filtering, column mapping, or manipulation on LOB data types. To select the tables you want to replicate, you basically use the table parameter, which is used by the extract process, and the map parameter, which is used by the replicate process. When you want to do data selection, data mapping, and data manipulation, you use the options of those two parameters. Luckily, most of the filtering options in those two parameters are identical, and they will be covered in this lecture. To select which rows to replicate, you use either the where clause or the filter clause of those parameters. To select which operations to replicate, you use the filter clause. The clauses call map, calls, and calls except are used to select which column you want to replicate. We will cover all of those options in this lecture. For basic data selection, you use the where clause of the table and map parameters. When this clause is used, the condition that you specify must be enclosed in parentheses. You will see examples of using this clause in the next slide. The major limitation of the where clause is that it doesn't support arithmetic operations. If you need this functionality, use the filter clause instead. The table in the slide is showing the supported evaluations in the where clause. You can reference the column names, use the comparison operators, numeric values, literals, and test functions. Being a DBA, you should be familiar with the first 4 items in the table. They are very similar to the conditions you use in SQL language. But the last item in the table is Golden Gate specific. They are called column tests, and I'm going to talk about them in the next slide. As implied by its name, the null column test is used to test if the value of a column is null. Present function is used to test if a specific column is present in the current operation, and absent function is used to test if the given column is absent from the current operation. But what does that mean? As you learned when you configured the supplemental logging on option, a database can be configured to log the values of only changed columns to the transaction log. In this case, if you update, for example, a title of an employee, the value of the new title will be present together with the primary key value. But the value of the date of birth, for example, will be absent. That's what present and absent mean. This leads to special consideration when you use where condition. I will show you this consideration in the next slide. The first example in this slide is showing how to replicate only employees whose location is in UAE to the target database. Please notice that this filter is applied using the map parameter, which means the replicate process will apply it. In this case, all the data has actually been transferred from the source to the target. And then the replicate process will apply this filter to select which row to apply. The second example is filtering the employees whose date of birth is null. The third example is filtering the employees whose salary is greater than or equal to 10,000. Notice how this example is using the present column test. This condition is telling the process that if the salary value in the transaction you want to apply is there and its value is greater than 10,000, then apply the row. You may wonder what will happen if you don't use the present column test. In this example, if the present column is not there and the process finds an operation of, let's say, an update to the date of birth, then the process will ignore the operation, output the transaction data to the discard file, and issue a warning message in the Golden Gate log file. To avoid falling into this dilemma, it is recommended to always use the present or absent column tests when you apply selection criteria on a column. Alternatively, you can make sure when you configure the supplemental logging option for a table or a schema to include the columns that you want to process in the parameter file. There are other ideas to deal with such a problem, and I'll explain it later in this lecture. Use the filter option to create more complex numeric evaluation than what the where clause provides. It only accepts numeric evaluations. However, this isn't practically an issue because you can mix filter and where clause in the same map statement and use the filter clause for the numeric evaluation and the where clause for the non-numeric conditions. Filter option supports the column conversion Golden Gate built-in functions, and this is probably the most powerful point about the filter clause. You can practically create complex conditions using the filter clause with the Golden Gate built-in functions. You can customize the filter clause to generate your own message, and also you can have multiple filter clauses for one table or map parameter. Also, you can have multiple filter clauses for one table or map parameter. The example is showing the syntax of the filter clause of the map parameter. And the table parameter has the same filter clause. The only exception is the filter clause in the table parameter doesn't support the raise exception option. Following are the elements accepted in the filter clause: Oracle Golden Gate column conversion functions, numbers and the columns that contain numbers, the arithmetic operators plus, minus, multiply, forward slash for division, and backslash for the remainder. All the known comparison operators are supported. The logical operators and or are also supported. The non-numeric evaluation cannot be used in a filter condition. For example, if you want to use the condition amount equals to the function present, filter will not be an option for you, and you must use the where clause instead. Here we have 3 examples of using the filter clause. As you see, you can perform arithmetic operations, call the Golden Gate functions, and specify the operations. The last example is showing you how to mix the filter and where clauses together in a map or table statements. The filter is used to make the statement take effect only on update operations and only when the salary value is greater than 1,000. The where clause is used to make the statement take effect only when the value of the salary column is available in the operation data. You cannot merge the 2 conditions together in the filter clause because filter option supports only numeric evaluations. I said earlier in the lecture that some databases write values of only changed columns in its transaction log file. If your where clause or filter clause reference columns that are not part of an update statement in an operation, that operation will be ignored and Golden Gate issues a warning message. To ensure the required data is available for the filters in the transaction log operations, you have the following options. If possible, make criteria refers to the primary key columns. primary key column values are always there in the transaction log data. If that is not possible, consider enabling the supplemental logging for the referenced columns in the source database. Another solution is to use the fetch calls or fetch calls except option of the table parameter. Those options instruct the source database to fetch the values of the columns if they are not present in the log. The fetch before filter option retrieves the column values before the filter or where clause is executed. The slide is showing an example of using those options. Finally, use the present column test to check whether the column is referenced by the current operation or not. When the table structures in the source database and the target database are not identical, you need to configure column mapping. Oracle Golden Gate provides column mapping in two levels, table level and global level. Table level is implemented by the clause call_map. This clause allows you to map the columns for individual tables, and that's why it's called table level mapping. Global level is implemented by the clause call_match. This clause allows you to test the column mapping for a group of tables, and that's why it's called global mapping. If a table in the source database and its mapped table in the target database share mostly the same column names and data types, and they only have a few different columns, the clause use defaults would be very handy. When you use this clause, you are telling Golden Gate that all the columns in the source table are identical to their corresponding columns in the target table, except the ones defined by the call_map or call_match functions. You will see examples on how to use those clauses in the incoming slides. The example in the slide maps the customer table in the source database to the contact table in the target database. It moves the customer gender column value to the gender columns. It concatenates the last name and first name columns to derive the full name column. I will cover the concatenation function in the next lecture. The example also automatically maps other HR customer columns to the HR contact columns that have the same name. This example of using the call_map clause introduces a parameter that I haven't talked about before. It is insert all records parameter. This parameter simply changes all the operations in the log into insert statements. You use this parameter to keep history of all the changes into a target database. The example is saving a history of the changes made on the invoice table in the source database into the inv history table in the target database. The history table has the same columns as in the invoice table. In addition, it has 3 extra columns. The first column holds the transaction commit timestamp. The second column holds the transaction operation type, which means it is update, insert, or delete. This indicator tells whether the current row is a before image or an after image. This applies to the update statements. Regarding the getInv built-in function, we will cover it in the next lecture. This example is showing how to use the call_match clause. This example maps the column employee ID to the column emp number, the column customer name to the column cust name, and the column leave ID to the column leave SN. These mappings will apply to the tables employees and leaves. So, if the employee ID column exists in the employees table, it will be mapped to the column emp number in the emp table. The same applies for the leaves table. If the employee ID column exists in the leaves table, it will be mapped to the column emp number in the leaves table in the target database side. In brief, the set of global column mappings you define in the top will apply to all the table mappings that come after. Notice the call_match reset parameter. This parameter turns off the global column mappings for the table mappings that come after that parameter. Therefore, the table's region and price will not follow the global column mappings. When you reference a column value in a filtering criteria or a column mapping parameter, you are referencing the after update image value. But sometimes you need to reference the before update image value of a source column. If you want to reference the before value of a column, you use the log all sub-cols parameter in the extract parameter file. In the replicate process side, use the @before column conversion function to reference the before value of the column. The example shown in the slide is an excerpt of a replicate parameter file, and it is setting the value of a column called delta. This column takes the value of the difference between the balance column in the source database after the update and its value before the update. As you see, it uses the before function to retrieve the value of the column before the update. You will learn more about the other Golden Gate functions in the next lecture. So that's it for this lecture. You have learned how to apply data selection based on where clause and filter clause. You also learned how to ensure data availability for filters. And finally, you learned how to perform column mapping. You will apply those concepts in the next practice lecture. Thank you.